Dear students, now we are going to discuss binary divider and its methods in detail with an example. Binary divider is a combinational logic circuit that performs the division of binary digits. Here, the binary division is similar to the decimal long division method. It is also known as the process of repeated subtraction. So, when compared with binary multiplier, it is little bit complex one. So, here we can consider one example 1111, that is 4 ones which is divided by 1 1. The decimal equivalent of the given problem is 15 divided by 3, that is equal to 5. There is no remainder. So we are going to get the same answer in terms of binary using binary division method. So in this method, we have to consider long division process. So here, this is the dividend, this is the divisor. So in the very first step, we are going to examine the bits of the dividend from left to right until the set of bits represent a number greater than or equal to the divisor. So we have to start examining the bits from left to right. Okay, in this dividend, first one is 1. That is smaller than 1 1. So then combine the next one also together. So here now we have got 1 1. So this is equal to 1 1. So at that time we can put 1 on the top of this long division and write 1 multiplied with 1 1 means we can get the same answer divisor as 1 1. Okay. In the next step we are going to subtract this value from this dividend. So subtracting means 1 minus 1 0, 1 minus 1 0. Okay. Then we have to move the next bit of this dividend. Okay, that is 0 is already there. So 1 is here. 0, 1. It is smaller than this divisor. So we have to put 0 because the condition is not satisfied. What is the condition? Here the dividend should be greater than or equal to the divisor. Here it is 0, 1. So it is smaller than the divisor. So we have to put 0 here. Okay. So then we have to move another bit. Okay, after putting 0 on the top, we have to move this 1. Okay, then now we have got 0, 1, 1 which is equal to the divisor. So now we can put 1. So 1 into 1, 1 is 1, 1. Then we can subtract this from the dividend. So we can say this as the partial dividend. Okay, because part of the dividend is moving. So here we can say 1 1 minus 1 1, we can get 0. So here the remainder is 0. The quotient is what? 1 0 1. Here 1 0 1 is nothing but 5 in terms of decimal. Do you all understand the long division method of binary division? This is the logic diagram of binary divider. So here we are going to use adder or subtractor. And then divisor is stored in the B register. Dividend is stored in the A register. We are going to use the register X for representing the quotient value. Okay. We can solve one problem step by step for understanding this logic diagram. There are two methods used for binary division. One is restoring division. Another one is non-restoring division. So this is the flowchart for this restoring division. So here we have to initialize the register X with 0 values and the dividend is stored in A register, divisor is stored in B register. Here N represents the number of bits used in this division. So the first step is to combine X register with this A register. After combining these two registers, we are going to shift that by 1 bit to the left side. Then we are going to subtract the divisor from the current X register value. We are going to subtract the divisor from the current X register value and the result is stored in this X register itself. Now we are going to check whether the X register value is less than 0 or not. If it is less than 0, we have to put 1 to this A register. Here n represents the number of cycles. If you are going to consider the very first bit of the divisor, we have to say it is A0. For the next bit, it is A1. For the next bit, it is A2. It is going on like that. Okay. So here, whenever this x is less than 0, if there is any unsuccessful subtraction. So in that case, if borrow generates means we have to say this a n is equal to 1. The nth bit of this a register, that is dividend register, is equal to 1, and then we have to restore the original x value as such. So for restoring this x value, we are going to again add this b with this x register. Do you all understand? That's why it is known as restoring division method. If x is not less than 0, that means there is no borrow. So we have to simply say an tends to 1 here. So then after this process, we have to decrement that count. Okay. So if count is not equal to 0, if the count is not equal to 0, we have to do the same process for the next bit. Okay. So here we have to do the same process for the next bit. If the count is not equal to 0, if count is equal to 0, okay, so that we can stop this process. Is that okay? Finally, we can get the quotient value in this A register and remainder is in the X register. So this is the flowchart for this restoring division method. So let's see the procedure for restoring division method. In the step 1, we are going to combine X register and A register. After combining the registers, then we have to shift the combined contents of X and A registers to the left by 1 bit. Then we have to subtract the content of B register, that is the divisor, from the X register. In the step 3, if there is no borrow in step 2, then put 1 in the LSB of A register. A register means here it is dividend. In the final step, it gives the quotient. Okay. And replace the content of X register by the difference value. So by this way, we can restore that X register value. If there is a borrow, replace the content of X register by adding the difference with the B register content. So in the last step, repeat the steps 1 to 3 for n times, where n is nothing but the number of bits in the dividend. Okay. So finally, the quotient will be available in the A register and remainder in the X register. Okay. So now we are going to solve one problem using this restoring method. Here consider the dividend is 1010, divisor is 0011. Here in decimal we can say 1010 is nothing but 10, 0011 is nothing but 3. So 10 divided by 3 is equal to 3 as a quotient, 1 as a remainder. The number of bits used in this dividend is 4. Okay, n is equal to 4. So in the first step, we are going to place or to store the values of dividend to A register, divisor to B register, 0 to X register. In the first cycle, we are going to combine X and A register together as like this. So X means 0000, A means 1010. Then we are going to shift this XA by 1 bit to the left. So we can get to the left means we can get 000. This 0 goes to this first place. So, okay, consider like that. So 0001, this one moves here. Okay, so by left means this. This is how we can move. Correct? So here we can get 0001, 0, 1, 0 and 0 here. Then the second step is to subtract the divisor from this X. So X is what? 0001. Divisor is 0011. So here we are going to subtract this. So 1 minus 1 is 0. 0 minus 1. So we need to borrow this value here. Okay. So we can assume that previous bits are 1, 1. Then only it becomes 1, 0. Okay. So here 1, 0 minus 1, 1. Okay. Then here 1 is there, 1 is there. So if it is a borrow, we have to consider like this. So here borrow is 1. So if borrow is 1 means replace the content of X register by adding the difference with B register. This is for restoring the X register value. So we are going to add the B register with this difference. What is the difference here? 1110. So this difference is stored again in this X register itself. So we are going to add the difference with this divisor. So we can get the value 001 as such in this previous one. So initially we have 0001. So we have restored the same value in the X register now. So now this XA becomes 00010,100. Okay. The first cycle is over. So next we have to now the n becomes 3. So here actually n is equal to 4 for the first bit. Okay. So we have done this steps. For the next bit we have to follow the same steps. Okay. So in the next cycle, second cycle, so here we have x is equal to 0010,1000 because we have shifted one bit to the left side. So now the x is having 0010, the divisor is 0011. So we are going to subtract it. So 0 minus 1. 0 minus 1 means again we have to borrow from the previous bit. So here if I am going to borrow this means it becomes 0. So here 1 0. So this is 1. So 0 minus 1 again we are going to borrow from the previous bit. So all the bits becomes 1 1 1. So here borrow is 1. Correct? So here replace the content of X register by adding the difference in the second step with this B register. So we can get the X register as 0010 now. Okay, this is the restoring value. The initial value is equal to the same. So now the XA is equal to 0010. Here X is 0010 and then A is 1000. So second bit is over. For the third bit, the third cycle, again we have to start with this XA. So here XA is what? Previous XA is 0010,100. So now we have shifted that XA register one bit to the left. So it moves like this. Okay. So here X is what? 0101. What is the divisor? 0011. So subtract 1 minus 1, 0. 0 minus 1, there is no possibility. We have to borrow from this one. So it becomes 1 0. 1 0 minus 1, 1. 0 minus 0 0, 0 0. So here the borrow is 0. So if it is 0, we have to put 1 in the LSP of the A register. Remember, if borrow is equal to 0, okay, borrow is equal to 0 means there is a proper subtraction. Correct. There is a proper subtraction here. So here we have to put 1 in the LSP of A register. So in the dividend register, we are going to replace the LSP, the least significant bit, as 1. So now the XA register as 0010, this value. Okay, since the borrow is 0 here, the proper subtraction. Correct. This difference is again stored in this X register. So X register is written as 0010 here as such. Correct. And then A register is what? 000 and the LSP is 1 because of this proper subtraction. So in the last cycle, so now we have shifted this XA combined register as 01000010. Correct. In the previous one, we have got 00100001. So that is shifted one bit to the left. So now the X value is what? 0100. So now we are going to subtract this X register with this divisor. So 0011. So 0 minus 1, it is not possible. So we have to borrow this and here it is 10. Okay. So 10. Consider 10. So we need to have the value for this. So we have to get this value here. Borrow 1 from this previous bit. So this bit becomes 1. So this 1 becomes 0. This value becomes 10. From this 10 we have borrowed one more value here. So 10 minus 1 is 1. Okay. So here 1 minus 1 is 0. 0 minus 0 0. 0 minus 0 0. So now the borrow is 0. Correct. That is borrow is 0 means proper subtraction. So it is a proper successful subtraction. So borrow is equal to 0. So if borrow is equal to 0 means put 1 in the LSP. Okay, of A register. Put 1 in the LSP means here This is the A register, correct? This is A, this is X, correct? In this A register, we have to put 1 in the LSB. So 0, 0 is already there, 1 is there. So one more 1 is added over here. So this becomes 0, 0, 1, 1. That is nothing but the quotient. 0, 0, 1, 1 means what? It is 3. Here it is 0, 0, 0, 1. The difference. Final difference in the X register is 0, 0, 0, 1. Correct? So it is nothing but the remainder. So 10 divided by 3, we can get the quotient as 3, remainder as 1. So now we have got quotient as 3, remainder as 1. Okay? So this is the binary division using restoring method.